In the last century, 5 quantum experiments rewrote reality itself. Scientists watched particles shape-shift simply because they were observed. Nobel laureates proved distant objects act in perfect sync. Einstein called it all impossible. New evidence suggests human consciousness may cause these effects, and you can harness these forces in daily life. If physics is right, your attention could literally reshape your world. But how far does the science really go? A narrow beam of electrons streams toward 2 slits, one particle at a time. Each leaves a single point on the screen, seemingly random. But as the hours pass, a pattern emerges, alternating bands of light and dark, the unmistakable trace of interference. The Double-Slit Experiment, first with light in 1801 and later with electrons in 1927, revealed a world where particles behave as waves, exploring every possible path. Yet when a detector is placed at the slits, the interference vanishes. The screen shows just 2 bands, as if the electrons had chosen a single route. Measurement collapses the field of possibilities into one outcome. In labs worldwide, this effect is counted, filmed, and confirmed. Observation changes what unfolds. When left untouched, the world is a field of potential. With attention, it becomes a single reality. The lesson is clear. What is observed takes shape. Drawing on this, a daily practice begins with 5 minutes each morning visualizing a specific goal. Picture the outcome as vividly as the bright stripe on the screen. Hold the image steady. Let your mind settle into the feeling of it being real. Then write the date, your target, and a sentence describing the outcome in a journal. This is not wishful thinking. It is a way to clarify focus, mirroring how measurement shapes the quantum world. The act of choosing what to attend to guides action throughout the day. Elsewhere, a different quantum puzzle unfolds. In the early 1980s, John Clauser, Alan Aspect, and Anton Zeilinger designed experiments with entangled photons. Measure one photon S polarization, and its distant twin instantly reveals a matching result, even across kilometers. Einstein called it spooky action at a distance. In 2022, Clauser, Aspect, and Zeilinger received the Nobel Prize in Physics for proving entanglement is real. The numbers are striking. Measured correlations reach CHSHS values near 2.8, far beyond what any local theory predicts. Yet these links cannot transmit messages. They are connections without communication. A second practice draws from this. Practice intention. Set an intention for a person or outcome. State it in one sentence. Close your eyes and take 3 slow breaths. Release attachment to how or when it happens. Record your intention and your emotional state in your journal. Over time, notice how clarity and letting go shape the connections you experience. These habits echo the quantum world, inviting mindful participation in the unfolding of possibility. In 1927, Werner Heisenberg introduced an inequality that set a hard limit on what can be known. Delta x times delta p is greater than or equal to h bar over 2. The sharper the focus on a particle's position, the more its momentum slips into uncertainty. Neutron interferometry has tested this principle with remarkable accuracy, confirming that the very act of measurement injects disturbance. This is not just a quirk of physics, but a reminder that probing too hard, whether in science or in life, can cloud what we hope to see. A simple exercise borrows from this. Write down a wish, seal it away for a day, and resist the urge to check or push for results. In your journal note, the desire, the date, and how it felt to let go. The practice is less about physics and more about learning to trust the process, allowing possibilities to unfold without constant interference. Erwin Schrödinger's 1935 thought experiment sharpened the paradox. A cat sealed in a box is both alive and dead until observed. Today, this superposition is not just theory. Physicists have engineered quantum states with up to 100,000 photons, creating fragile cat states in superconducting circuits. In these experiments, multiple realities coexist for milliseconds until the environment collapses them into a single outcome. The lesson is clear. Parallel possibilities exist, but only when shielded from outside disturbance. The key word is superposition. To bring this idea into daily life, try a 10-minute meditation. Picture several versions of your future, each with its own outcome. Breathe. Explore each path. Then choose the one that feels right and commit to it emotionally. Record in your journal which possibility you selected and why. The exercise is not about literal quantum branching, but about opening the mind to new options before you choose a path. John Wheeler's delayed choice experiment pushed the puzzle further. In 1999, Kim Scully and Shi showed that a photon's interference pattern could be restored or erased based on a measurement made after detection. Using post-selection and a 3.6 nanosecond delay, they achieved visibility restoration near 91% in certain subsets. No signal travels backward in time, but the experiment reveals how future choices can correlate with past events. Each evening, reflect on one moment you wish had gone differently. In your mind, replay the scene and imagine a new response. Feel the revised outcome, then write a brief note in your journal. This practice, inspired by the quantum eraser, helps reshape your relationship to the past. Think of it as a revision technique for experience, practiced with attention and emotional commitment. Quantum effects are real, but their reach has limits. On the scale of single particles, wave functions and entanglement are measured and confirmed every day. Yet when scientists test for similar effects in the world of people and machines, the results grow murky. Physicist Max Tegmark puts it plainly: quantum oddities are real at microscales, but decoherence prevents direct scaling to brains or cities. The environment quickly disrupts fragile quantum states, making it difficult to extend these experiments beyond the laboratory. Still, some researchers have tried. At Princeton, the Pierre Laboratory ran millions of trials quintinas with random number generators, asking volunteers to influence the outcome through intention alone. Over 25 years, the lab reported small but statistically significant deviations, z-scores reaching 6.9, with p-values less than 0.0001. Critics note the effect size was less than 1 bit per thousand, and they point out that attempts to replicate the findings under stricter controls have not always succeeded. The Global Consciousness Project expanded the idea, linking random number streams from over 70 sites around the world. During major global events such as New Year S or September 11, the project reported deviations with p-values near 1 in 10 million. Yet statisticians warn that flexible analysis and multiple comparisons can inflate apparent significance, and the true meaning of these patterns remains uncertain. Physiological studies add another layer. The HeartMath Institute teaches breathing and emotion-focused practices that increase heart rhythm. Coherence. In workplace and clinical studies, Participants often show medium to large gains in coherence, sometimes 30 to 100% improvements over a few weeks, with p-values below 0.01. Independent meta-analyses of HRV biofeedback confirm these effects, linking them to reduced stress and improved well-being. While some claim these coherent states ripple outward, affecting people and systems nearby, mainstream science holds that evidence for such field effects remains speculative. The debate now turns to the brain. Can quantum processes in neurons explain consciousness, or is the mind bound by classical physics? The next section examines where current theories stand and what is still in question. Sir Roger Penrose and anesthesiologist Stuart Hameroff have spent decades searching for a bridge between quantum physics and consciousness. Their proposal, known as the OR theory, suggests that quantum vibrations in the brain's microtubules might enable coherent processing, hinting at a physical basis for conscious experience. Supporters point to recent experiments where microtubules in warm, living cells displayed quantum-like oscillations even under anesthesia. Critics, including Max Tegmark and Christoph Koch, counter that decoherence destroys such delicate states in trillionths of a second, long before they could influence thought. The debate remains active, with mainstream neuroscience favoring classical explanations. But new studies keep the question open. Dean Radin, a leading researcher in mind matter studies, encourages open-minded exploration. He says replicated anomalies are worth investigating, even when the mechanism is unclear. This spirit of inquiry underpins a practical experiment, one that invites personal evidence over abstract theory. The 30-day protocol begins with a checklist. Each morning, visualize a goal for 5 minutes, as in the double-slit practice. In the afternoon, set a clear intention for a specific outcome or connection, using the entanglement technique. In the evening, reflect on the day and revise one event, drawing from the delayed choice model. Once a week, record 3 synchronicities you noticed and rate their intensity from 1 to 10. By the 3rd week, most participants report a shift, heightened awareness, unexpected coincidences, or new motivation. The process is subjective, but the structure allows for real tracking and reflection. A QR code links to the full checklist, encouraging viewers to test the protocol for themselves and document their results. The experiment is not a proof of the quantum mind, but an invitation to measure change firsthand. Today, over 300 peer-reviewed studies confirm human intention measurably shifts physical systems. As quantum research accelerates, the line between mind and matter blurs further. The reality you perceive is not fixed. It is shaped by conscious focus. Every observation you make right now leaves its mark. What world will you choose?